Good morning, student. Let's start today's class. Okay. In today's class, we will continue our discussion about power solar thermal power plant. Okay. Our unit is solar thermal power plant, and in previous class we have seen that the in engineering aspect the solar thermal power plant is uh, now or the solar thermal power plant have four parts, okay, or four systems. First one is solar collection system. Today we will discuss that solar collection system, about solar collection system. Okay, there are several feasible methods for collection and conversion of solar radiation into heat. Okay, uh, in previous unit which is solar collectors, in solar collectors we have seen so many types of solar collectors which collect solar radiation or convert solar radiation into heat energy, and by using that heat energy we can generate electricity or heat our room or swimming pool, etc. Okay, so we have seen so many types of solar collection systems. That solar collection system that these solar collector systems we used in the solar power plants. Okay, and they are given below, means that solar collector system given below. Okay, the types of solar collector system. Okay, first one, first one is a solar pond. Okay, so previously we have seen about solar, what is solar pond, how solar pond is worked. Okay, here we shortly briefed or shortly describe. Okay, in solar pond what happened, the direct radiation as well as the diffused radiation, this is direct radiation and this is reflected or diffused radiation, okay, falls on the water of the pond, which have the layer of salinity. That means the salt dissolved in the water is different, or the density of the salt dissolved in the water is different. That upper layer, this upper layer is low uh, salt level, okay, or low salt mixed, and the below or bottom layer is highly salted water. Okay, and this difference density or difference in salinity is helped to retain the heat from the sun. Okay, and heat collected, and that from the bottom the salinity water is transferred by through or by through that salinity water we transfer the heat. Okay, and here you see C is, and here C is concentrating concentration or concentrating power equal to 1. Okay, this concentrating power is nearly equal to 100 uh, or up to 100. Okay, this concentrating power is reached up to 100. Okay, and the temperature, this temperature, this solar pond give the temperature T less than 80 degrees Celsius. Okay, this solar provide temperature less than 80 degrees Celsius, and the power by power we get from the by using the solar pond is 5 megawatt. Okay, less than 5 megawatt. Similarly, this is solar chimney. You have seen previously what is solar chimney. There is a chimney or a this is the chimney. Okay, this is the cylindrical shape chimney. Okay, and there is a heat collection. This is the heat collection what heat collection device. Okay, and the upper layer is heat transport or translucent collection air. Okay, that means the upper layer is translucent, that means transparent. Okay, and the below that there is heat collector. Okay, then when the both direct radiation and uh, diffuse radiation fall on the transparent layer, okay, the heat is captured by the heat collection, okay, then the the heat is transferred to the required uh, mechanism or required generator, okay, and by this method the C is 1 and temperature is less than 150 degree Celsius and P is less than 5 megawatt, okay. then one system is parabolic dot collector, okay, parabolic drop collector. That parabolic drop collector, okay, is that a parabolic mirror are there, okay. This is the parabolic mirror, okay. One absorber rod is there, okay, and that and between that rod a fluid or a heat collection fluid is flowing, okay. That heat collection fluid may be oil or water or anything, and that heat collection fluid which is flowing through the absorber transport the heat from or transport the heat from the absorber to the destination, okay. And here only direct radiation is used or direct radiation is reflected to the absorber through the this parabolic mirror, okay. And here the C is 40 to 80, okay. This is due to this is concentrating collector, because these two are non-concentrating collectors, okay. These two are non-concentrating collectors, that's why the concentrating power is less, 1 okay. Here the this is a concentrating collector. So here what happened, here the parabolic mirror concentrate the solar radiation to the or focus the solar radiation to the observer, okay. This is observing rod, okay. And another one is heliostat collector. You know previously heliostat, what is heliostat? These small mirrors, plane mirrors is called heliostat, and this plane mirror is placed in such a way that it uh, reflects the falling direct radiation onto it to the absorber, okay, to absorber which is placed in a tower, okay. This is the absorber, this placed in a tower, okay. And these small mirrors placed in a manner or in an angle that it focus the falling radiation into the onto the absorber, okay. And this heliostat mirrors only use direct radiation, and this is also a focusing or concentrating collector, so that the C is concentrating power is 200 to 700, okay. And in the power plant, in the solar power plant, we used that we use that collectors which have a concentrating power is nearly equal to 100, okay. and and the heliostat collector temperature raised to 1500 degrees Celsius, and the power is 4200 megawatt, okay. And next is this is concentrating, okay. This is non concentrating, okay. This is also non concentrating. This what the flat plate collector, okay. Previously we have discussed about flat plate collector. What is the flat plate collector? A plane is a reflector is there, okay. And in that reflector, okay, there is a rod, okay. There is absorbing rod, okay. That absorbing rod has a heat transporting fluid, okay, inside, okay. And the both direct and diffuse radiation fall on the flat plate, and the flat plate, and the heat is absorbed by that rod, absorbing rod, and the heat transfer using the fluid, okay, through the heat transferring fluid, okay. And due to the this is the non-concentrating collector, and C is equal to 1. Temperature is very less, it is 200 degrees Celsius. Power is less than 1 megawatt, okay. Similarly, one is vacuum tube collector. Vacuum tube collector means there is a reflector. This is a reflector, okay, and there is and there are rods, okay, and that rods, okay, is not containing any thermal liquid or thermal fluid. It is vacuum, okay. So the heat, uh, it is vacuum, and the heat is transferred using oil, water, or organic fluid, or similarly as a flat plate, okay. And uh, this this is and this in this concentrating here, C is 3, temperature is less than 250 degrees Celsius, and power is 1 less than 1 megawatt, okay. And one another is, or last one is concentrating parabolic dish, or paraboloid, okay, paraboloid mirror. And here the parabolic disc, or parabolic shape disc, and one absorber is there, heat absorber, okay, in the place of focusing point of that parabolic disc. This parabolic disc focusing point is here, okay, and that at that point one absorber is there, okay. From that one absorber, heat transferring oil or air is running. And when the direct radiation, here only direct radiation is used, when direct radiation is fall on the disk, it reflects or it focus all the radiation to the absorber, and we get heat from the absorber by the transporting oil, okay. And here concentration, concentrating collector, here concentration C is 300 to 250, okay, and temperature is less than 1500 degrees Celsius, and power is less than 150 kilowatt per unit, okay. Now we see what type of collectors we can use in our or in our thermal power plant. Now let's discuss about that collectors briefly, okay. The concentrating configuration is commonly with air, liquid. No, the concentrating configuration in combination with air, liquid, coil, uh, coil, metal, oil and metal salts, or water steam as primary heat transfer fluid, have been favored concept in the most of the thermal solar power plant. That means in thermal solar power plant, in mostly we used concentrating collectors, okay. uh, and the concentrating power C is nearly equal to 100. That means the collector we used in the solar thermal power plant have the C concentrating power is nearly equal to the 100, okay. The following and the lowering the investment cost for lowering, that means for lowering the investment cost, we can also use non-concentrating uh, collector like a solar pond, or solar pond or vacuum tube collectors. Both concepts are suited in principle to supply low to medium temperature process heat. That means that these two, solar pond or vacuum tube collector, these two have or give low temperature, okay, low to medium temperature. Okay, the solar pond is capable of operating off sunshine hours, also due to the thermal storage in the pond. In the solar pond can be worked or can be used when there are no sun rays or at the night time, due to the solar pond have uh, heat absorbing storage, okay, inside the pond. Okay, and the point focusing parabolic disk or the line focusing parabolic disk throw system should consist of a collector field. We can also we can use our concentrating collectors for the solar power plant. Okay, and there are two type of solar concentrating collector. One is point focusing collectors, and one is line focusing collector, and both of have consist of a collector field, that means which is collecting the solar energy. Okay, the power plant the solar power plant using such a field, okay, of collectors are called distributed collectors and distributed receiver or farm system. Okay, the power plant which use that solar collector field type collectors, or the point focusing parabolic disk, or linear focusing disk, or line focusing disk, parabolic, that power plant is called that field is called distributed collector or distributed receiver. Okay, for point focusing thermal solar power plants, concentration of uh, direct radiation is done by heliostat, and these have large focus length to focus the radiation onto the centrally located receiver in center or the tower solar power plant. Okay, in which we can use the heliostat for point focusing. Okay, due to that, the heliostats, the mirrors, or the heliostats focus the all reflected radiation onto a point. Okay, another solar thermal concept utilized an entirely different non-concentrating systems, that is a solar chimney consists of translucent plane with a large area above the ground and a centrally attached vertical column. Okay, we can also use a solar chimney. Okay, we can used previously discussed all three all four, that means these techniques, these 1 2 3 4 5 6 7 techniques in different solar power plant, as we need how much energy from that solar power plant, we can use different type of solar collector system. Okay, thank you.